हेलो गाइस, मेरा नाम मोहम्मद इज़ान खान है. All right. And currently I am pursuing my degree in civil and environmental engineering from IIT Patna, right? So we were doing a topic on limits and derivatives. So let's move on and see what question do we have next. I think that we had to do from question number 24 itself. So let me start from there. Yeah. So let's begin. तो हम लोग को क्वेश्चन दिया हुआ है. Our limit has been given from x tending to a, and I have a sine x minus sine under root x minus under root a. All right. So if I just put on the trigonometric formula on this, which happens to be my 2 sine x minus a by 2 multiplied with cos x plus a by 2. This might help me somewhere. So let's see what does it give me. Limit extending to a, and in the denominator I have root x minus root a. All right. Now, what can we do? Further, we can multiply with the conjugate. Yeah. So let me just write it again in a shorter font. So my limit x is tending to an a. I have a sine formula product with the cosine one. In denominator, I have a root x minus root a multiplied with its conjugate. Yeah. All right, I can do this. Then what happens is multiplied with this. Okay, and in denominator, what will I get? I'll simply get x minus a. All right. So let's move on. What can we do further? So since I made the denominator as x minus a, so I can just make this as p, and I have that same formula on sine. Yeah. So if I put x minus a is equals to p, what happens is I'll be getting the equation as such: sine p by 2 cos x plus a by 2 times under root x plus under root a whole divided by p. All right. Now, what can I do? What if I just give it a multiplication by 2? Yeah. So I'll divide this by 2 as well, and here I'll get a 2. So this sine p by 2 divided by p by 2, and limit x is tending to a. When limit x is tending to a, p is tending to 0. So for this part only, I'm just writing for that. When x will tend to a, p will tend to 0. Alright, you can see it from here. So limit p tends to 0, right? And I have a sine p by 2 divided by p by 2, and I have a 1 by 2 as well, into my limit x is tending to an a, and further I have cos of x plus a by 2 multiplied with, okay, so this will give me a 1, and what will this give me? 2a by 2, so cos a, and product 2 times of under root a. So 2 and 2 will get cancelled out. Under root a times cos a will be my answer for this problem, right? So let's move on further. Let's see what question do we have next. Next up is question number 25. So what is question number 25? My limit x is tending to a pi by 6. What am I having here? I'm having a cot square x minus 3 divided by a cosec x minus 2, right? So cot and cosec are interchangeable, right? How can I change this? 1 plus cot square x is equals to cosec square x, and I can write my cot square x as cosec square x minus 1. All right. So let's move on further and see what we can do with this information. I'm just going to put my limit to pi by 6, right? And I'm putting my cot equation in this. So, and the whole thing is divided by a cosec as well. So, what am I getting here? I'm getting a cosec square x minus 4 divided by cosec x minus 2, right? What can I write this as? My limit x is tending to a pi by 6. In denominator, I'm going to have a cosec x minus 2, cosec x plus 2. And in denominator, I had a cosec x minus 2. Alright, so what are we going to be left with? My limit is tending to a pi by 6. I'm having a cosec x plus 2. So what will it be? Cosec pi by 1 by sine pi by 6, pi by 6 2. So this will just give me a 2 plus 2. The answer will be 4. Alright. So let's move on to the next question now. Next I have question number 26, right? So in question number 26, what I have been given, I am having my limit x tending to 0, root 2 minus 1 plus cos of x whole divided by sine square of x, right? So cos 1, 1, 2, root 2, 0. Yeah, 0 by 0 form. So let's move on. Let's see what we can do with this. The quickest thought I have is multiplying it with a conjugate. Let's see if that helps. Let's just multiply it with its conjugate, right? All right. It is going to leave me with this. And in denominator also, I have a sine square of x. And in product, I have under root 2 plus whole under root of 1 plus cos x. See, I don't have any problem with this equation. Why? Like for this part, when I will put x equal to 0, as x is tending to 0, this will give me a positive value. This is not going to be 0. So I'm okay with this. I just had to clear up this numerator part. So I multiplied it with the conjugate. Right. So let's see what it leaves me with. 2 minus 1, 1 minus cos of x. Still 0, still 0, it is going to 0, and there's a sine square x as well, so it is a 0 by 0 form. So further I have to simplify this, right? Let's just write this first, the whole thing, whole root of 1 plus cos of x. Okay, now what can I do? 1 minus cos x. Let's see, and in denominator I have a sine square of x. So double angle formula, yeah, that might help us. So cos x को I can write it as 1 minus 2 times sine square of x by 2. Alright, so if I just put this equation there, now what do we have? We have 1 minus cos x now, so I'm going to write it as 2 times sine square x by 2 divided by sine square x. Alright, and in product I have under root 2 plus whole under root of 1 plus cos of x bracket closed. Yeah, what can I do with this sine square x? Again, double angle formula might help me. Sine square x by 2, 2 sine x by 2 cos x by 2, the whole squared, so 4 times of sine square x by 2 cos square x by 2 under root 2 plus under root 1 plus cos x. Alright, now yeah, so 1 by 4 cos square x by 2 under root 2 plus under root 1 plus cos of x. Limit x tends to a 0. So this part will be 1, this part will be root 2 plus root 2 root 2, 8, 1 upon 8 root 2 answer. So the answer to this problem is 1 by 8 under root 2. Okay, let me just check the calculation back here. I think there's something wrong with the last part. Okay, it's not visible. Let's see. So again, if I do this, I had a 1 by 2 and it was multiplied with what? Under root 2 plus 1 plus cos 0 is 1. So 2 root 2. 2 root 2. So 1 by 2 times 2 root 2. So 1 by 4 root 2. Yeah, this is your answer. Alright, let's move on further and see. Next up is question number 27. Yeah, question number 27. I have a limit x tending to 0, sine x minus, question number 27. Yeah, sine x minus 2 sine 3x. Sine 5x. This is a simple question now. So basically what happens is, if you just open this up, like I don't know why they put this question so far up the exercise. This is a very easy question. You can put the limit x tending to 0 sine x by x minus limit x tending to 0. These are 2 and you want a 3 here, so 6 times sine 3x by 3 x, right? And plus, what do we have? We have a sine 5. So limit x tending to 0 with a 5, and we have a sine 5x in the numerator and 5x in the denominator. What will it be? So 1 minus 6 plus 5 equals to 0. Alright, so let's move on. In the next question, it is given to me the limit for some entity and they want me to find the value for k. Alright, so I'll just be having to solve the left hand side and right hand side separately, and I can just compare the values. Okay, so on the left hand side, what do I have? I have a limit x tending to 1, right? And x raised to the power of 4 minus 1 divided by x minus 1, all right? And this has to be equated with what? Like, on the right hand side, what do I have? X cube minus k cube and things like that. So if we want to do this like with the L'Hopital rule, so we have this formula, right? X raised to the power of n minus a raised to the, I'm just comparing it, okay? And x minus a. So what does this leave me with? N minus 1. The value for this, if you do it with L'Hopital also, you will get the same thing. What is a is 1 and n is 4. So you are getting left with a and n minus 1, and this has been given as what is there? N is 4, right? A is 1 raised to the power of 4 minus 1, right? This is equals to 4. So LHS we have equal to 4. Now let's solve for the RHS as well. So on RHS, what do I have? In RHS, I have a limit of x tending to a k, and I have a x cube minus k cube. I have a x square minus k square, right? So now I have to open this up. Okay, what can I write with x cube minus k cube? I can just simply write this as x minus k times x square plus k square plus, all right. And for what? X square minus k square, I can simply write this as x minus k and x plus k. These both things are in division, so I'm getting left with this part only. X square plus k square plus xk whole divided by what? X plus k. Now, if I just put the limit for k, like limit x was tending to a k, right? So I'll be getting what? K square plus k square plus k square. So 3k square divided by k plus k 2k, right? So I have 3k square divided by 2k. So 3 by 2k is getting equated to what? What was LHS? LHS was 4. So k is equals to 8 by 3. Yeah. So this is the value for k. This is the answer. So basically, what did you have to do in this question was, you have to solve separately the LHS part. You can find out the limit for LHS part, and that same thing is equated to some entity, and then you have to find the value for k. So it is basically the same question that you have been doing further up. You just had to equate those two limits to find the value of k, right? Now let's move further. So in the next question, what do we have? We have differentiate each of the function with respect to x. All right. From 29 to 42. All right, we can do this. So what is the function given as? Function of x is given as what? x4 plus x cube plus x square plus 1 whole divided by x. This division part, this is to, like these are problems in x cube plus x square plus x plus 1 by x. Now you can differentiate easily. What will I have? 2x plus 1 plus x raised to the power minus 1. So minus 1 times minus 2. So x minus 2. Okay. So what am I getting left with? 3x square plus 2x plus 1 minus 1 upon x square. Okay. Let's move on. Question number. What is the next question? Question number 30th. Like, question number 30th. Yeah. I think there must be a bracket like this. Alright. Let me draw it. Let's see if I can draw it. It is not helping me these days. So there has to be a bracket like this, and then a power of 3. Alright, perfect. So now I can solve it in many ways. Like I can cube this whole thing. There are two ways. Method one. Let's see. Method one is just simple like this. Squared into 1 plus minus x bar minus 2. Alright. One is this. Other method is like you can open this up, this whole thing up. I'll do that on the next page. So on opening that up, what I'll be having x cube plus 1 by x cube plus 3a square b. So I'll just write it as 3ab, 3ab and a plus b. A plus b. Yeah. So x cube plus 1 upon x cube plus 3 times of x plus 1 by x. Alright. Now I can differentiate this part easily. I'll be getting a 3x square here. X raised to the power of minus 3. So x minus 4 plus 3. 1 minus x raised to the power of minus 2. So this is the answer that I'm getting. You can do it with either ways. Like you don't have to compare your answers. You just have to, follow the you can follow any path, just you should have that proper differentiation techniques, right? Nothing else. Your answer must be coming different if you are choosing, like if you are squaring it first, like you're cubing it first, then you are differentiating. That will be a different answer, but that will also be correct. Okay, so both the methods are correct. You just have to differentiate properly. So let's move on to the next question, which is question number 31. 3x plus 5, 1 plus tan x. Same thing goes here. Like you can differentiate it like this. You can consider two functions a and b, and then a d by dx of b plus b d by dx of a. You can do it like this also, or otherwise you can just open those brackets up and multiply a whole thing, and then you can proceed. So it is upon your choice. Your answer must be coming different, but that will also be the correct answer. Okay, so don't need to panic and all. So let's just do this with method first. I'll be going to write 3x plus 5, and on differentiating this part, I'm getting a sec square of x plus in the product. I have 1 plus tan x. On differentiating the first part, I'll be just left with a 3. So now you see, this is the easier one. Okay, you don't have to first multiply the whole thing, and then you'll also have to do this, the chain rule, when you will be differentiating 3x tan x. So this is the better rule. This is the better method. Okay, let's move on. Let's see what's next. So now what do we have? Yeah. Okay. So the next question number 32, right? So in question number 32, we have sec x minus 1 multiplied with sec x plus 1. So now I'll be having a sec square x minus 1. If I differentiate this whole part, this is my fx. If I differentiate this part, what am I going to have? I'll be having what? I can simply, just to play with it, tan square x is equals to tan square x plus 1 equal to sec square x. So sec square x minus 1 will do what? Tan square x. Just to play with it, like it was clearly visible to me. Like I can't help it. I had to write it like this, tan square x. Now if you just differentiate tan x is sec x tan x. Alright. So sec x tan x. What am I going to have? 2 tan square x times sec x. Alright. So this is your final answer. Let's move on further. Next up is question number 33rd. So I'm having a 3x plus 4 divided by 5x square minus 7x plus 9. One thing I want to tell you, right? Like there's a you must know this formula first of all. At this point, you must be knowing this formula, obviously. But whenever you see something like this, don't just start applying this formula like you'll be putting v equal to this, u equal to this. It will be a big hassle for you. All right, and the answer will look very dirty. So, like, it's just my suggestion. You can do that. It's okay. You can do that. In your board also. In your board, you can do that. In JE also, you can do that. But in JE, they want you to, simplify it. They'll give you some terms to find out. Like they'll just say when the answer is coming, there's some nx. So you have to find that value of n. So if you'll do it like this, you'll have to simplify it further, further, further to get to that point. So what I suggest is you simplify this whole thing and then do this. All right. So let's see what we can do. 5 9 5 is 45, and what am I having here? I'm having a 7. So 9 5 is 45. 15 3 is a nothing. 5 9. Okay, 15 3. No. So you can't simplify this further. It is the simplest form. Then you have to come back to this. Like I'm just going to consider v as this, u as this, and then no. You can't just compare. You have to take v as the one in the denominator, u in the numerator, and then proceed. I'm sorry, I'm fumbling too much today. Right. So we'll just be putting v. V is what? 5x square minus 7x plus 9, the whole square. All right. In denominator, what do we have? In numerator, 5x square minus 7x plus 9, all right. And then differentiated numerator is 3 minus 3x plus 4. And differentiated denominator, 5 to 10x minus 7. All right. So this is what you are getting here. Let's just try to simplify it further. Either I'm going to have 15x square minus 21x plus 27 minus 30x square plus 21x whole divided by 5x square minus 7x plus 9. Alright. So this 21 is going 28, 27, 28 is 55. Right, so let's just write it like that. Whole divided by 5x square minus 7x plus 9. It was raised to a square. Alright, so this will be your final answer. Question number 34 is function fx has been given to me as what? x5 minus cos of x whole divided by sine of x. So let's just proceed like that. In the denominator, I'm going to have a square of sine. In numerator, I'm going to have a 5x4 minus cos x will give me sine x plus sine x, right? Plus sine x minus x5 minus cos x, and sine x is going to give me a cos x. All right. Now I'll try to simplify this further. Yeah. This is your final answer. Let's see what we can do next. Next up, we have question number 35, which is x square cos pi by 4 divided by sine x. All right. Cos pi by 4 constant 1 by root 2. I'll take it out. X square upon sine x. All right. Now we just have to solve this part. So I'm going to do this on the next page. On the root 2. And in denominator, I'm going to have what? Sine x the whole square. In numerator, I'm going to have sine x times 2 of x minus x square. Sine x ka differentiation is cos of x. So 1 by under root 2. And if we want to simplify it further, we can do things like this. 2x sine x divided by sine square x will be nothing but 2x by sine x minus x square cos x by sin x. I can write this as tan x, or otherwise I can just write it like this. Yeah. So this is your answer. So next up is question number what? Question number 36. Question number 36. Fx is given to me as, so fx has been given to me as ax square plus cot x and p plus q cos x. Yeah. So if we apply the chain rule here, this differentiated with p plus q cos x, so it will be 0 minus q sin x. And here I'm going to have plus p plus q times of cos x and 2ax minus cos x square of x. Right? Cos x square x. Alright. So the final answer will be what? Minus q sin x. Ax square plus cot of x plus p plus q cos x multiplied with 2x minus cos x square of x. Alright. Let's see what we can do next. This was your final answer. Okay. Next up, we have been given the function as fx equal to a plus b sin x divided by c plus d of cos x. Alright. So now c plus d cos x का whole square, alright, and c plus d cos x multiplied with a will be 0, b sin x minus b cos x, and in numerator I will be having a plus b sin x as well, multiplied with what? C will be 0, d cos x, d minus d sin x plus d sin x. Alright. Now you can move on and simplify it further. Let's do that if we can here. So there will be a b. Yeah. So I'll be having a b cos x times c plus d times of cos x plus d sin x, a plus b times sin x, whole divided by c plus d of cos x the whole square. Alright. Let's open up the bracket, see if we can able to simplify it further. bc cos x plus bd cos x. No, bd cos square x, right? Yeah. ad sin x and bd sin square x plus bd of sin square x. Yeah. So bd we can simplify. So bc cos x plus ad sin x plus bd. Like bd sin square x plus cos square x will be equal to 1, right? And in denominator also I have a c plus d cos x the whole square. So this will be your final answer. It may look dirty, but that is what it is. Moving on. Next up is 38. Best approach for 38 is, I'll say that, square up the whole thing. Place to a square, right? So sin square x plus cos square x will return a 1 plus 2 sin x cos x. Nothing but sin 2x, right? Sin of 2x. So this is your most simplified version. You'll be differentiating this. You'll be getting a 2 cos 2x. Here's your answer. Yeah. So let's move on further. Question number what? No, 39. 39th में fx I'll be having what? 2x minus 7 का square multiplied with 3x plus 5 का cube. Alright. So I'll be just going to apply the chain rule here. 2x minus 7 का square times 3x plus 5 का square times 3 plus 2x minus 7 multiplied with the 2 times 3x plus 5 का cube. Okay, so now I'll be just going to simplify it now. On simplifying it, I'll be having what? Let me clear up this page first. I'll be left with a 9 2x minus 7 का square, 9 2x minus 7 का square, 3x plus 5 का square plus 4 3x plus 5 का cube 2x minus 7. Alright. Now, let's see what do we have next. Next up is question number 40th. And question number 40th. It is. So there is an x square sine x plus cos 2x. So 2x sine x plus x square cos x plus minus 2 sine 2x. 2 sine 2x, 2x, 2. Yeah. So this is the final form also. You can simplify it further if you want, but there is no need for it. Hello. Function is given to me as sine cube x multiplied with cos cube x. Okay. Okay. Yeah. Sin x cos x का whole cube. Okay. 8 into sin x cos x. Bring this 8 here and bring this 2 inside. 2 sin x cos x का cube. So 1 by 8 sin 2x का whole cube, right? Now it is simple. 1 by 8 times 3 sin 2x will be sin 2x ka square. Sin 2x will return a cos 2x and there will be the extra 2 as well. So I'll be writing 2. So 2 will be 1 by 4. 3 is also there. So 3 by 4 sin square 2x cos 2x. Again sin 2x cos 2x. I can write it together, club it. So 3 by 8 sin 2x is there as well. 2 sin 2x cos 2x will be sin of 4x. So 3 by 8 of sin 4x and sin 2x. Alright. Let's move on. Question number 42nd. I can write this as ax square plus bx plus c. Then raised to the power of minus 2. Then I'll just be differentiating whatever there is inside. So 2ax plus b. Alright. So this will finish up our question number 42. Now, what do we have next? We have question number 40, long answer type. Differentiate each of the following with respect to x using first principle. Okay. So, let me just guide you through the first principle now. Suppose I've been given a function fx. And what do I have to find? I have to find f dash of x. Like I have to differentiate it. Then dy by dx of that function will be limit h tends to a 0. Function fx plus h minus function of x whole divided by h. Alright. So this we have to do. This is the first principle. Now using this we have to differentiate the following functions. So let's see. Fx is given to me as what? Fx is given to me as cos x square plus 1. And what is fx plus h? Fx plus h is given to me as cos x plus h ka whole square plus 1. So fx plus h cos x plus h ka square plus 1 cos x square plus h square plus 2xh plus 1, right? This is the fx plus h part. Now I'll be just having to put the values in, and that will be a limit question then. Okay, so limit h tends to a 0. Fx plus h is what? Cos x square plus h square plus 2xh plus 1 minus a cos x square plus 1 whole divided by nh. Tell me what is cos a minus cos b? This is minus 2 times of sin a plus b by 2 multiplied with the sine of a minus b by 2. Alright. Just compare A and B with the following, and uh, you know, okay, let me solve this. So minus 2 times limit of h tends to 0 times sine of x squared plus h squared plus 2xh a plus b plus 1 plus x squared plus 1 whole divided by 2 times sine of x squared plus h squared plus 2xh. Okay, minus x squared minus 1 minus x squared minus 1 by 2, the whole thing. I'm going to be left with this only. 2x squared plus 2xh plus h plus 2 whole divided by 2 multiplied with sine of h square plus 2xh by 2 whole divided by an h as well. Yeah. So on simplifying this further, what do I get? I have a sine h. Yeah. So let's see. I have a sine 2x square plus 2xh plus h plus 2 whole by 2. I can't do anything with this as of now. But yeah, I can write this sine h plus 2x by 2, and I had an h in denominator, right? So I can do this h 2x plus h by 2 and 2x plus h by 2 here as well. So what? Yeah, minus 2. Limit h tends to 0. Limit h tends to 0. That part will be 1, and I'll be left with 2x plus h only. First I have to write this sine whole thing 2x square plus 2xh plus h plus 2 whole divided by 2, and that sine h 2x plus h divided by h 2x plus h by 2 whole thing will be a 1, and what is further 2x plus h by 2. So let me write this simplified version. I'm just putting h equal to 0 here, so minus 2 times of sine 2 x square plus 2 by 2 times x square plus 2 by 2 multiplied with a 1 multiplied with 2x plus 0 by 2. H has been put equal to 0. So what am I going to be left with? I'll be left with what? Minus 2 times minus 2x times sine x square plus 1 minus 2x. Yeah, minus 2x times sine x square plus 1. Yeah. So I'll be left with this minus 2x sine x square plus 1. You can also check this. I'll just differentiate it like normal. Minus sine x square plus 1 times 2x. So minus 2x times sine x square plus 1 is the correct answer. Now let's move on further. Let's see what do I have to do. So next up, what do I have? Fx has been given to me as ax plus b and cx plus b. What can I write? Fx plus h, a times x plus h plus b divided by c times x plus h plus d. Alright. Now, if I just put in the values in that formula, I'm going to have what? Limit h tends to a 0, a times x plus h plus b, c times x plus h plus d, and fx here ax plus b divided by cx plus d, cx plus d, whole thing divided by nh. Alright. Now a x plus h plus b cx plus d minus ax plus b c x plus h c times x plus h plus d whole divided by and h c x plus h plus d times c x plus d. Alright, I can write it like this. Now moving on forwards. So limit h tends to a 0. I have a acx times x plus h plus axd plus ahd plus bcx plus bd minus acx. I'm just multiplying the whole thing. X plus what? X plus h minus axd minus bcx minus bch minus bd. Alright, I'm sorry for this mess. Alright, so this is getting cancelled out. Axd is also getting cancelled out. And what now? Um, like they must be bcx is also getting cancelled out. I wrote bcx somewhere over here. I can't find it now. So what am I going to be left with? My limit of h tends to a 0 simply and ahd minus bch whole divided by h times c times x plus h plus d times cx plus d. Alright, if I'm going to put the limit equal to 0, I'll be left with what? It's going to an infinity form. BCH is there, alright. So I'll take h common from this AD minus BC C times x plus h plus d multiplied with cx plus d. Just put h equal to this 0 here. Alright, we'll be left with what? AD minus BC divided by cx plus d ka whole square. Right. So this is your answer. Now, what do we have here? We have function fx. Function fx has been given to me as x raised to the power of 2 by 3. So how can we proceed with this? Let's see. So fx plus h can be written as x plus h to the power 2 by 3. Alright. And okay, let's just plug in the values. H tends to a 0. X plus h to the power 2 by 3 minus x to the power 2 by 3 all divided by an h. Okay. I can do a binomial expansion here. Yeah. Okay. On doing a binomial expansion, I can write this as x raised to the power 2 by 3 plus 2 by 3, x raised to the power 2 by 3 minus 1, right? Times h and plus h square x and further whole divided by an h. Yeah. And in the end, we have minus x 2 by 3 also. So let me just write it again here. X 2 by 3 plus 2 by 3 x 2 by 3 minus 1 times h plus h square something something something, and in the end what I'm going to be getting is x raised to the power of 2 by 3. Alright, this whole thing is divided with nh. So if I just simplify it now, yeah, this and this is getting cancelled out. Okay, so I'll be having what? 2 by 3 x minus 1 by 3 h by h plus limit h tending to 0 and h square by h is there, and further like you'll be having this limit further down the line, and this is going to be equal to 0, whatever part will be there. You'll be getting an answer with this part only. So 2 by 3 x raised to the power minus 1 by 3 is the correct answer for this part. Okay, let's move on. Evaluate. How many questions are left on this? So question number 46 is also with the first principle. So fx has been given to me as x of cos x. I can write fx plus h as x plus h cos x plus h. Okay. I have to open this part. So I can write this as x plus h times cos x cos h minus sin x sine h. Okay, x cos h minus x sine h plus and h cos x plus h. All right. So if I just simplify it now, I'll be going to put a limit h of tending to 0, and I'll be having in the numerator s cos h minus x sine h plus h cos x plus h minus x cos x. Yeah, and the whole thing divided with nh. So you have to break it now. So I can write this as limit h tends to a 0, x cos h minus 1 whole divided by h minus limit h tends to a 0, x sine h by h plus limit h tends to a 0, h times cos x plus h by h. Yeah. So now putting the values for this also, yeah. So let's move on. Since there was a cos h minus 1 by h and h was tending to 0 like this was there, cos h. If limit h is tending to 0, this part will be equal to 0. So that first part will be going to a 0. And for the next part, what do we have? This part has gone to 0. Next up, we had an x sine x, and limit was sine h upon h. That will be 1. So minus x sine x is there, and plus cos x plus h. Limit was h tending to 0. So there's a plus cos x term as well. So I'll be left with what? Minus x sine x plus a cos x. So this is your answer. All right. Now let's move forward. Next up is question number 47th. What is it? Limit y tends to a 0. I have an x sec x plus y minus x sec x sec x plus a y sec x plus y. I can write it like this, right? So I have a y in denominator as well. So limit is y tending to 0. All right. Let's see what we can do with this. So I can write it like this, or I have a x by 1 by cos of x plus y minus x upon cos of x whole thing divided by y plus a limit y tends to a 0, y times sec x plus y divided by y. Limit y tends to a 0, x times cos x minus cos x plus y divided by y cos x plus y. Okay, and there's a plus sec x term as well. Cos a minus b, 2 sin a plus b by 2, sin a minus b by 2. So I'll be going to be left with this 2 sin a plus b by 2, x plus y by 2, and sin a minus b by 2. So x plus y minus x by 2 whole divided by y of cos x plus y, and there's a plus sec x term as well. Yeah, so x times limit of y tends to a 0 and 2 times sine 2x plus y by 2 and sine y by 2. Okay, so in denominator what we did, cos x was there and cos x plus y was there, and there's a y by 2. If I just ignore this 2 up here, I can write this as like this. So sine y by 2 divided by y by 2 and limit y tends to 0. Okay, that will return a 1. So x limit y tends to a 0. sine of 2x plus y by 2 whole divided by cos x plus y times limit y tends to 0 sine of y by 2 divided by y by 2, and there's a plus sec x term as well. Okay, that is constant. Now if we just put the value for y equal to 0, we'll be left with what? X times sine x upon cos x, so cos square x minus 1, yeah, minus 1 times sec x. So what is this? This is basically tan x sec x, so x tan x sec x sec x, yeah, x tan x sec x minus x, this whole thing, and there's a minus x, this is plus, this is a plus sec x as well, so I can take sec x common. I'll be left with what? X tan x plus 1. So this is your final answer. So I think let's end this session here. We'll continue the next questions in our next session. I think we are done for today.